All right, in this second example, we'll just look at problem 283 in the textbook for section 3.5. And we're supposed to use the the integral table to find the integral of arctangent x cubed over x to the fourth dx. You remember arctangent, that's the same thing as inverse tangent. And so I'm going to look in my basic integrals, nothing there. Keep scrolling down. Trigonometric integrals, well, they don't involve inverse trig functions, so keep scrolling. Exponential and logarithm integrals, keep scrolling. Hyperbolic integrals, well, these aren't hyperbolic trig functions. Inverse trig functions, there we go. So this is inverse tangent. So we'll look for inverse tangent of u. Well, I have, inverse tangent of some angle, albeit x cubed, but I'm divided by some power of x. So I really want a product here of the inverse tangent and something, but not this simple, unless I could do a clever substitution. Here u would have to be x cubed, and du would be 3x squared dx, but I wouldn't be able to eliminate this x to the fourth. So let's keep on scrolling. Here we go. Formula number 67. Okay, so I'm going to pause here. I'll steal this here and move it over here. But what I want you to do, pause the video here. See if you can't rewrite this integrand here so that it matches what we have here. All right. So pause the video now. Try to get this form to match this form. You're going to have to do a substitution here. When you think you've got that form matched, we can apply this rule. When you have that form matched, go ahead and hit play again and compare your results with mine. All right, so I've copied down the form that we want to get to and the resulting integral. Okay. So here, I want to pick u to be x cubed because I want inverse tangent of u, and I don't have that. So clearly u must be x cubed. Du is going to be 3x squared dx. I don't see an x squared dx piece. All right. So 1/3 du will be x squared dx. There it is. So I don't have an x squared term in the numerator. So I force the issue. I multiply by x squared at the same time I divide by x squared. This is just a multiplication by 1. Okay. So this becomes x to the 6th in the denominator. But I can pull it to the numerator as x to the minus 6. This would be inverse tangent of x cubed with an x squared dx on the outside. So now when I do my u substitution, u will be x cubed, so that'll be a u. X squared dx will be replaced with 1/3 du, so there's the 1/3, there's the du. And now this is not going to be u to the minus 6. We have to be careful here. U is x cubed, so u squared would be x to the 6th. But this is x to the minus 6, so this is going to be u to the minus 2. So there we have the complete form now that's in the form we can readily use. Notice that n can't be minus 1, and we don't have that here. N is minus 2. So now go ahead and pause the video. Hopefully you got this form that we can directly apply this. Go ahead and apply this formula in the integral table to what we have here and check your results. So pause the video now, apply the formula, and check your results with me when you're done. All right, so now we've got this form. Here it is, 1/3 u to the minus 2 inverse tangent of u du. Applying the formula. Okay, so we've got a 1/3 that stays there, 1 over n plus 1, but n is minus 2, so this is going to be a negative 1 here. So 1 over minus 2 plus 1, that'll be a minus 1. So I should have a minus 1/3 all the way out in front. There it is. Okay. Then u to the n plus 1, so that's minus 2 plus 1. That's going to be a minus 1. U to the minus 1 is 1 over u. Okay, so there's the u to the minus 2 plus 1. Inverse tangent of u. Okay, so that's going to show up as a 1 over u inverse tangent of u, right? Because this is u to the minus 1. Minus the integral of u squared, quantity u to the power of 2 minus 1. Okay, but this is going to be 1 over u. So because u to the minus 1 is 1 over u. And here's the 1 plus u squared in the denominator. So here we've got it to this far. So Again, we still are in u space, recognizing that u is x cubed. So I've got quite a bit done here, minus 1/3, okay, because there's a minus 1. 1 over u shows up here, inverse tangent of u, minus this integral. But now how do we do this integral here? Okay, I would recommend that you set this up with partial fraction decomposition. So what I want you to do now is only focus on this integral here. Ignore the minus sign, in fact. Just look at this integral here and go back to what we did in 3.4 with partial fraction decomposition. So pause the video now here. See if you can't compute this using partial fraction decomposition. Okay. Once you have that, hit play and test your results with what I get. So focus only on this now. All right, so remember partial fraction decomposition. I have a factor here, u, that's linear. I have a quadratic factor that's irreducible. That means the only roots of 1 plus u squared are plus or minus I. So I can't factor this over the real numbers. So that means I can rewrite this rational expression as a over the factor u plus bu plus c over the factor 1 plus u squared, because this is an irreducible quadratic polynomial. So then this expression is equivalent to this one. The reason we want this expression is so we can use either a u substitution or natural logs on finding these integrals. So equating this expression with this expression, I'm going to do a common denominator. So here I'm going to have a times 1 plus u squared, right? A times 1 plus u squared, and bu plus c times u, bu plus c times u. That'll give me the entire numerator being a plus 1 over u squared plus bu plus c over u, all over this denominator of u times 1 plus u squared. But I have the same denominator here, so the numerator, which is right here when I do that, must equal 1. Okay, so I've got that equaling to 1. If I expand this out, I'm going to have an a plus au squared, right, and a bu squared plus cu. That all must equal 1. So that means the a plus b, which would be the coefficients on u squared, must be 0 because there are no u squareds here. Similarly, the coefficient c has to be 0 because, well, there's no u terms over here, so c is 0. Finally, a is the constant, but that a must be the 1 here, so a equals 1. Well, if a is 1, then a plus b equals 0, imply b is minus 1. So c is 0, there's no c term here. b is minus 1, so it's going to be a minus u over 1 plus u squared, and a is 1. So we can rewrite this as 1 over u minus u over 1 plus u squared. Remember, the integral of 1 over u is simply natural log u. And here we have to do a substitution. Okay, so I'm going to pick v to be 1 plus u squared. V is 1 plus u squared. dv is 2u du, and there's the u here. So dividing by 2, I get 1/2 dv is u du. Okay. And so if I replace that here, I'm going to get a minus 1/2, 1 over v dv, and that's going to be a natural log v here. All right, with a minus 1/2. Oh, but v is 1 plus u squared. So I'm going to have natural log u minus 1/2 the integral of 1 over v, which is natural log v, but v is 1 plus u squared. So there we have it. That's the integral of this piece here. Okay, so now we can go back and combining from above. So there's the minus 1/3 1 over u, inverse tangent u. There's the minus 1/3 1 over u, inverse tangent of u. Okay, and then from this piece here, we're going to minus 1/3 times the minus is going to be positive 1/3. It's going to be positive 1/3 times all of this. So we have a positive 1/3 times natural log u, and a positive 1/3 times minus 1/2, that's minus 1/6, natural log 1 plus u squared plus c. So now, remember, we're not done, because this is in terms of u, but remember, the original u substitution that we had, all the way back at the top, u is x cubed. Okay, so go ahead, pause the video, and make sure we can do some simple substitution here. Rewrite this in terms of x using the substitution u equals x cubed. When you have it all finished, go ahead and hit play and compare your results. All right, putting in x cubed here. There's x cubed, there's the 3, there's the minus. Putting in x cubed, that's inverse tangent of x cubed. Putting in x cubed here, I have 1/3 natural log x cubed. Putting in x cubed here, we've got 1 plus x to the 6 because that's being squared. Finally, the last little detail, I've got a constant in front of a log, so I can bring that in as an exponent. So x cubed to the 1/3, of course, the cube root undoes the x to the 3rd power, leaving just natural log x. So there's the final conclusion here. So even though we have an integration table, it still involves doing clever substitutions. And even here, we had to reduce this by using a technique in 3.4 where we had partial fraction decomposition.